Okay, so let's go with the lesson 2. Lesson 2 is a RAC databases overview and architecture. So where we are, up to this point, we learned Oracle Clusterware. And we know what is Oracle Clusterware. It is installed in the clustered environment to create Oracle cluster. And once you have an Oracle cluster, then you can create real application cluster databases. And without real application cluster, typically you will have only one instance and one database, one-to-one relationship. So you have a database in the storage, but to manipulate your data in the storage, we need an access point. That is instance. So client connects to instance to access to underlying storage and pull out information and cache into the instance, and then we manipulate data. Okay, that's one-to-one relationship. If you have an instance crash, and there will be database crash because there will be no more an access point to Oracle database. So, if you can have a multi-instance database, which is called the RAC database, this will be big plus in terms of a high availability and big plus for your business in terms of continuous service to the user or applications. And we're going to get into the overview part of this area a little bit, and then we're going to get into a high-level architecture in this area. Okay, so after completing this lesson, you should be able to describe benefits of Oracle RAC. Okay, there are many benefits, and explain the importance of global resources. And behind the scene, to keep integrity of a RAC database, we use internal resource management that is called global resource management. So we will have to discuss a little bit about this area. And in lesson 7, we have a global resource management lesson, and in that lesson, I will get into more detail. And also describe global cache coordination, how your memory structures are grouped together, keeping consistent image of the data. And that's another thing what we have to discuss. We learned in our cluster. So in the first bullet, cluster consists of multiple independent servers interconnected. From client point of view and user point of view, we are connecting to one of the servers in the cluster as a single system. In the clustered environment, okay, we install Clusterware, and once you install Oracle Clusterware, then we can create databases. With the Clusterware installed in Oracle Cluster, you can create single instance database. So one instance in a particular server as access point to Oracle database. Or you can create a multi-instance database. So you start instance 1 in node 1, instance 2, node 2, instance 3, node 3, as an access point to the same database in the underlying storage. So you can create a RAC database as well. Okay? So in the clustered environment, you have choices. And there is one more thing, RAC one-node database. RAC one-node database is a single instance RAC database. You can understand this way. Because RAC one-node database, it doesn't require Oracle cluster where Oracle Clusterware software is installed. At any given time, we keep single instance, active instance. But if this instance goes down, and this can be restarted, or it can be failed over to another server in the same cluster. So we can use this feature as well. So in the clustered environment, you can create RAC, single instance database, and RAC one-node database, and also RAC database. So you have one of the 3 possible choices. And when you look at third bullet, non-cluster Oracle databases, I can say single instance database. Single instance databases have a one-to-one relationship between database and instance. An instance is a memory structure and background processes. And database here is physical structure. And Oracle RAC embodiment have a one-to-many relationship between the database and instances. Now we had this discussion, so let me go back to one of the slides, what we learned in lesson 1 slide, and we had this discussion, okay? And I'm gonna move this a little bit up. ASM, when we discussed in our ASM storage solution, I used this diagram, okay? So in this case, and we have a disk array 1, 2, 3, 4, and these are all in the storage area, okay? It could be in a vendor's storage, it can be Oracle storage. And also, you have a compute node here, so host 01, host 02, host 03, host 04, and host 05. And these are compute node. In each compute node, we create, let's say, 2 node instances. So you start one instance in host 01, another instance in host 02, and this has an access point to Oracle database. So you have an access point here, but your actual database is residing in underlying storage, okay? And you can also create single instance database in this location, and it is access point to database striped across physical disks and underlying storage. And also, you can have another database. You have another 2-node RAC database. It is access point to another database striped across physical disks. So you can create single instance RAC 1-node database and RAC database in this way. Okay? So let's come back to the slide. Yeah, we'll make it smaller. And let's move on. And this is in a typical Oracle RAC architecture. Okay, so let me actually point out here. We have a storage that's in storage. It can be ASM storage or NFS storage, or it can be any other supported storage. And underlying storage is presented to node 1, node 2, and node 3. And then we started in 3 instances. And this is called the 3-node RAC database out of a 3-node cluster. Because you have 3 instances, that's a 3-node RAC database that is running out of 3-node cluster. Okay? And how does the application connect to your database? It depends on your service deployment and application deployment. One possible option is more like the slide example. And in this slide example, we have this. We have HR service. And you create a service in instance 1. So that is HR service. And you want to start this service only in instance 1. And you can configure instance 2, instance 3 as the backup instance as HR for the HR service. And also, instance 2, we created and started the sales service. And also, instance 3, we created and started call center service. Now, as you can see here, we started only one service in one instance. One service, one instance. One service, and one instance. So that's in the embodiment here. In this case, from application side, we can create connection pool to connect to instance where particular service is running. For example, I can create one connection pool by using maybe HR service you create another connection pool to make connection to sales and call center. By doing so, all your HR application traffic will be isolated in instance 1. All your sales and call center application traffic will be isolated in instance 2 and instance 3. Now, this is an example of workload partition. You don't want to make unnecessary block traffic and message it in a transfer. So you only start a particular service in a particular instance. So this is one possible option. Or no. So this is too small RAC database. Three node RAC database. So it's okay to start all 3 services across all 3 instances. I'm fine. So you can also configure your environment like this. So if that is the case, all HR application workload, sales application workload, and call center application workload will be spread across all 3 instances. Or you can create a service to run only subset of your RAC database. For example, during one particular time period, sales service or sales application requires more resource. So I'm going to actually start sales service only, sales service from node 1, instance 1 and instance 2 to leverage resources available between two instances. And also, I will start HR in instance 1 and call center in instance 3. Now, if that is the case, in instance 1, you will have 2 services running, HR and sales. And then what you can do, when needed, you can create resource manager plan, and you allocate more resources based on importance of application workload in the given time. So you have many different ways to deploy your application on RAC database. And in my example, I gave 3 examples, but there could be more examples available. Okay, so let's take a look at RAC 1 node. What is a RAC 1 node? I'm going to show you this first. I have a RAC 1 node diagram. Okay. So let's take a look at this. The picture in the left-hand side is a RAC 1 node database example. In the picture in the right-hand side, it is a RAC database example. In both cases, I made one assumption. The first example, RAC 1 node database, this is a cluster 01 that consists of 3 servers. In the right-hand side, we have a cluster 01 that consists of 3 servers. Okay, so 3 node cluster and 3 node cluster. Now, the difference is, in the left-hand side, we have a RAC 1 node database with the different sizes. In this case, I have a DB01, and assuming that this is a RAC 1 node database, meaning that this can be running out of this and this anywhere based on your requirement. And also, I have a small database here. I will name it DB02. I have a bigger database. I will name it DB03. And these are all RAC 1 node databases, which means that I have 3 databases running out of 3 servers. In the right-hand side, I have a single database, but it is a RAC with a RAC configuration. I have a 3-node RAC database, so we can access to same database from node 1, node 2, node 3, instance 1, instance 2, and instance 3. So we can access the same database with from the different instances. Okay, the slide, what we saw, that is covering this area, RAC 1 node database. Okay, in this example, we created 3 RAC 1 node databases like this. In this example, we have a DB1 and DB2 and DB3. At some point, if you have some maintenance work, for example, I have a host 01 patching that is scheduled. If that is the case, you have to stop this instance. That will actually affect your application and users. So what we want to do is, what I'm going to do, before maintenance work, I want to relocate this instance from host 01 to host 02. Online operation is possible. So instead of actually killing DB01 and then start DB01 in host 02, for a certain amount of time, it's possible to keep the DB01 out of host 01. There is a timeout setting. In addition, we add additional database instance. So for a short amount of time, you can keep two instances, one for existing connections, one for the new connections. And then once a timeout expires, then we're going to kill DB01 to keep DB01 in host 02 only. That's what we can do. So, and then we're going to perform a patching process. Once patching is done, then we can actually relocate back, so we can keep DB01 in host 01 in this way. That's what we can do. And the other one is, it's also same. If you have actually heavily loaded the server, then you can also relocate RAC one node database from one server to another server. So we can use a RAC one node database, different purposes. One example is in high availability, or to perform online relocation in case of planned maintenance, and also balancing a load. Those kind of features available. But when you compare between RAC one node and RAC database, which one is better? Definitely RAC database is better, because a RAC one node, it doesn't support scalability, because at any given time, you only keep single instance. But versus RAC database can have multiple instances. Whenever needed, you add additional instances, so that way you can support more transactions and more users. That is a benefit, okay? So even though RAC one node database can give you a lot of benefits, but RAC database is still better. But if customers are not ready for RAC database yet, then the customer can upgrade single instance database to RAC one node database first. At later point, once everything is ready, then they can actually upgrade RAC one node database to RAC database. The question is, how many steps are needed to convert RAC one node to RAC database? Only very minimal commands, okay? Because your RAC one node database is a RAC-enabled single instance database. And there are only minimal steps are needed to convert it to RAC database. And also converting back to RAC one node database is also very simple. And this topic will be covered in the later lessons. We have one lesson that covers RAC one node database. And we will discuss more on implementation side in that lesson. Okay? In lesson 2, we only learn up to this point. I think this is more than enough to discuss a RAC one node. But there are a few more slides I will go through. So here we have online database relocation. That is a feature name. Online database relocation is a feature name. Okay? It's possible to create additional instance for a short amount of time as a part of a relocation. And then we use it as part of maintenance, and also to support load balancing. And there are many features. There are many cases where we can use online database relocation. And the same technique can be used to relocate RAC one node instances to high capacity servers to accommodate changes in workload. And also a single client access name allows client to connect to a database regardless of where the service is located. That's another thing. Let me actually go back here. And we had a discussion on scan. And let's see. Okay, this is an example of a scan. So in this case, and we have a scan definition in the DNS. Okay? And suppose that you don't have instance 2 and you don't have instance 3, and your database is a RAC 1 node database, for example. How can I connect to this RAC 1 node database? When client requests the connection, DNS will pick one of the 3 IP addresses, round robin fashion. Let's say 192.0.2.203. Then connection request is forwarded to the scan listener that is running out of 192.0.2.203. Now what it does is it will return the location of RAC 1 node service. Because we only have a single location to access the database, so scan listener must provide current location of RAC 1 node instance. And the client receives that information and then connects to local listener where active RAC 1 node instance is running, and finally we can make connection. Just like this, we use the same concept, scan, and also scan listener. That's what we use. So let's come back here. Single client access name allows client to connect to the database regardless of where the service is located. And Oracle RAC 1 node database can be easily scaled up to full Oracle RAC database if it contain if the customer needs more the resources for better scalability. Okay, so this is an example of creating RAC 1 node database. Assumption is you already installed Oracle Clusterware in Oracle clustered environment, and you install the RAC database software, and you start up DBCA. And when you start DBCA, and you have option here, you can create Oracle RAC 1 node database, and also you can create a single instance database. You can also create a RAC database. So you're going to use a DBCA to choose database type. And storage solution. For RAC database and for RAC 1 node database, underlying storage must be shared storage. Okay? So Oracle's recommendation is when you build a RAC database and RAC 1 node database and leverage ASM storage, because there are many good benefits of ASM, extent-based striping and metering, and also online reconfiguration and online maintenance. And there are many good features of ASM. So the direction is using and leveraging ASM as a RAC database solution is a recommendation. Okay? And what about Oracle Clusterware? And there's one small change in the Clusterware area. When you install Oracle Grid Infrastructure to install Oracle Clusterware, and we need to share the storage for RAC, the OCR, and voting disk. Starting with the 12.2, you must use ASM as a storage solution for OCR and voting disk file. That is mandatory. Now, at the database level, you have more possible choices. You can create your database in the NAS storage, network attached storage, or you can use ASM storage, or you can use a vendor's cluster file system, or general cluster file system. There are many solutions available, but many customers currently use ASM. It is also current and future direction of RAC database storage, and this is highly recommended. What about network connectivity? at the clusterware level, we learned that the minimum number of network interfaces are the minimum number of network interfaces is 2. One is for public, and the other one is private. In the RAC database level, we also need 2. One for private, one for public. Okay, so your RAC database network requirement is the same as your clusterware level network requirement, and your RAC instances communicate each other by using UDP protocol for Linux and Unix environment. And Windows environment, it uses TCP connection. Now, let's get into benefits. What are the benefits of a RAC? And every time when I teach RAC training, many customers mention that performance is a RAC database benefit. Yes, it could be, but performance benefit, it depending on your workload pattern, and we will have to discuss this in next few lessons, the next few pages. The actual benefit for sure in RAC environment is high availability. If one instance goes down, that's fine. We have another access point because a RAC database is a multi-instance database configuration. And also, RAC database is a good solution for scalability. So with a 2-node RAC database, it currently supports 100 transactions per second, for example. And I'm expecting additional workload in next few months. Then you can add additional instance for better scalability. Okay, I'm not talking about performance at this point. So high availability, that is a good feature. And scalability is another good feature. Yes, that is for sure. So, if you need more transactions and more users, yes, add more servers for better scalability. Okay, so let's see cluster and scalability. If your application is running and also scalable in SMP system, then same application also scalable in RAC environment as well. Because the SMP system and RAC database model is very similar. When you look at this diagram, it's showing you that. In RAC database, we use a shared everything architecture. So we have a shared storage in this area. Oops, I will move back. So we have a shared storage in this area. And also, we have instances, which include SGA and background processes. And these instances communicate each other, and the content must be maintained correctly. So we also use a cache fusion algorithm to keep consistent image of a cluster, actually at the database level. So it's very similar to SMP model. So if your application is scalable in SMP model, yes, your application will be scalable in RAC database environment as well. Okay, so in order to improve scalability, what are the which components should be considered? So if I add one server, am I going to get 100% scalability benefit directly? No. There will be always overhead. And also, there will be many other factors that give you better scalability benefit and less scalability benefit. For example, so I'm adding additional server and with a disk input output hardware. Okay, for example, your underlying shared storage in a network is, if this is in a network attached to storage, maybe gigabit, for example. Or if your storage is in SAN storage, then maybe 5 channel, maybe 16 gig per second channel. Or if you are using InfiniBand network, and that is active-active, then the throughput, it can be up to 10 gigabytes per second, which is equivalent to 80 gigabit per second. So depending on which input-output subsystem you are using, scalability benefit will be different, definitely. And what about inter-node communication? Are you going to use 1 gigabit network, or are you going to use the bonded network, or are you going to use a 10 gigabit Ethernet? Are you going to use InfiniBand network? There will be factors. And what about operating system and number of CPUs? You are adding additional server to run your database instance, but how many CPUs can be CPUs can be used? Okay, if your environment is the Exadata, the Intel-based server, and your server is X7-2 server, for example, then you can have up to 48 CPU cores. That's the database servers, one of the latest database servers from Oracle Exadata environment. That's your Oracle engineering system. Versus you may have actually just a small database server. So small number of CPUs versus 48 CPU cores. That makes a lot different. But what about your the database management system, and meaning the version of your database? The feature availability will be different. And very importantly, what about your application design? And these are all factors that give you better scalability and also worse scalability benefit. These are all the considerations. So you will have to choose the right solution to meet your requirement. Now, let's get into some concept of a scale up and speed up area. And here we have one example. With the original system, and suppose that in the given hardware, in the given time, you can perform 100% of the work. And if you add up additional hardware, then you can do double the work and triple the work. And that gives you a scale-up benefit because you can do more work in the given time. But what about benefit? What is speed up concept? Speed up concept is to be able to perform same amount of work. I need only the less amount of time by adding additional server. So I can do same amount of work in the less amount of time. That's a speed up benefit. In RAC environment, depending on your pattern of workload, you can achieve a scale up benefit, and you can also achieve a speed up benefit. But in certain workload, you may not be able to achieve speed up benefit. And here's the example. So we have three different workload pattern here. And you have OLTP type of a workload pattern. And then we expect response time sensitive queries here and transactions. And decision support system with a parallel query. So we do expect long running query or I/O intensive queries, and also batch query. This is a part of mixed workload pattern. And when you look at here, in OLTP and internet workload pattern, by adding additional servers and to create bigger the RAC database by adding additional instances as well, we can get scale up benefit. So if we could achieve 100 transactions per second with a 2-node RAC database, by adding additional instance, you can have a better scalability. But what about speed up? You may not be able to achieve a speed up benefit because in OLTP and internet workload pattern, we expect response time sensitive queries. Response time could be sub-second or a few seconds. Okay? In RAC environment, to keep consistent image of a cluster, we use the metadata management, and that is covered in lesson I believe 6 or 7. I believe 7, and we use global resource management operation behind the scene. So that will add up some additional overhead when performing OLTP and internet pattern of a workload. Even though overhead is very minimal, but we are expecting response time sensitive query that may be a little bit the height percentage over the total response time. So that's why it may keep about same performance but not better performance compared to single instance versus RAC database. Now, decision support system with a parallel query. When you run a long-running query, and you can leverage multiple instances by starting multiple parallel execution servers, and definitely you will get better performance benefit because RAC related overhead is very minimal, but you gain more from parallel execution across multiple instances. And also you can get scale-up benefit as well. And with a batch load, you have a possibility to achieve speed-up benefit and also scale-up benefit. Yes, for sure, you can get a scale-up benefit. So in most of the cases, you can get scale-up benefit, but speed-up benefit, it depending on your workload pattern. That's what we can learn from this slide. Okay, so let's take a look at I/O throughput balanced. When you configure a RAC system, and it is to run RAC database, and you create RAC database to support your application, and your application is to support your business. So when you configure RAC system, you will have to collect requirements from your business, from your application, from your database to meet the requirement. The most important area is I/O subsystem. In many cases, when you observe performance of your RAC database for your application, I/O bottleneck is one common area that slows down your entire system. So if you can design your RAC system eliminating the potential I/O bottlenecks, then you can run your RAC database optimally. And this example is giving you a very simple, high-level example of configuring your systems. Okay, I will actually give you the component one by one to give you a better idea. So let's take a look at this. And this is full node RAC database. So what I'm going to do, let me do it this way. I'm going to copy this, and I will put it in here. So that way I can use annotation. And then what I'm going to do, I'm going to lock this. Okay, so let's take a look at this. So I'm looking at this area. Enterprise, in this example, we have a full node cluster. So host 01, host 02, host 03, and host 04. So we have 4 servers in the cluster. And each server consists of 2 CPU cores, for example. Okay, it's a very simple example. So each CPU can process at a rate of 200 megabytes per second. And since we have 2 CPUs in each server, and each server can process 400 megabytes per second. Across 4 servers, we can process data at a rate of 1600 megabytes per second. Now that is a maximum processing power in the compute node. Now to be able to process at this rate, your data must be pulled up from the storage and then cache it back to database server in the same rate. To do so, you will have to consider storage network interface. So in this case, we have a host bus adapter. Host bus adapter, in this example, it can deliver data at rate of about 200 megabytes per second, in this particular example. And since there are 2 host bus adapters in each server, total is 8. So that is 1600 megabytes per second. So, we can deliver data from the storage back to compute node at rate of 1600 megabytes per second. So we can process this amount of data per second in the compute node. Now, what about your 5-channel switch? And suppose that we have one switch that can deliver data at rate of 800 megabytes per second. Now, if we have only a single switch, that means even though your host bus adapter can transfer data back and forth at rate of 1600 megabytes per second, because of a 5-channel switch, your I/O performance will be slowed down. So your bottleneck will be 5-channel switch. So in order to balance, you add more. So you have 1600 megabytes per second. And also, you have a disk array. Each disk array has 1 2 gigabit per second controller. So from this one disk array, we can read and deliver data at rate of 200 megabytes per second. So which means that if your database only resides in one disk array, that means we can deliver data only at rate of 200 megabytes per second. It's not good. So your database in this example must be spread across 8 disk arrays. So that way, we can achieve 1600 megabytes per second that can be delivered back to compute node in the same rate, that can be processed in the compute node in the same rate. That is an example of I/O subsystem design in RAC environment. But this is a high-level example. In real environment, you will have to work with the storage admin, and you will have to work with network admin, system admin, and also you will have to gather information from application team to configure your environment in this way. Okay? Now, good news is Oracle introduced Oracle Engineer System, and the latest version is Exadata Database Machine X7-2. And when you go with the Exadata Database Machine, which is engineered system that was designed for Oracle database, when you go with an Oracle Engineer System, your hardware component already tested and configured and optimized. Because of that, you don't really spend time on hardware configuration to balance I/O throughput. When you're looking at this in a simple example, with the Exadata Database Machine X7-2 full RAC configuration, and you will have 1, 2, 3, 4, 5, 6, 7, 8 node cluster. This is in a full RAC configuration. And each compute node comes with 48 CPU cores. And the database software is installed here, and clusterware is installed here, and ASM software installed here. And also to balance disk I/O transfer, we actually installed 2 InfiniBand switches. And in the storage level, to maximize the spindles, we added 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 Exadata storage servers. And each server comes with 20 CPU cores. And also there is the flash memory space, and there are 12 physical disks in each Exadata storage server. And all these components are balanced and tested and configured. Okay? So that's one nice testing example. So we can use the Exadata database machine configuration if you are looking for balance the system to run your database optimally. That's one example. So let's come back here. So now let's take a look at the usage of global resources. And number one, the example here, and this is two-node RAC database. And we are making one simple example. And we have data in the storage, and data is the 1008. And suppose that one user connected to instance 1. And also, we made some changes here. And we committed. So in instance 1, data committed, and committed data is 1009. But in the storage, the data is still before image. Why? Because we're not going to actually desynchronize data in the physical storage at commit time. If that is the case, that will make excessive disk IOs. At commit time, we only copy description of changes, which is a redo, into the online redo log file. However, the actual physical data block synchronization is done at checkpoint. So it is before checkpoint, for example. And another session logged in to the second instance and requested the block and tried to modify data and committed. Oops, we already committed the data in instance 1, and another session from instance 2 tried to make changes and commit. Then we have a data divergence. The problem is when session is performing operation in instance 1, session 1 or instance 1 must notify instance 2 about this activity. And instance 2 must be aware of activities in instance 1. So that way, instead of making physical I/O, if the latest data in the remote instance, then we pull out information from remote instance instead of reading it from physical disk. So keeping this information across instances is very important, and this feature is called global resource management. Managing all these resources in the cluster level, is very important. In lesson 7, we're going to get into this area, and this is called global resource management. Okay, so some additional memory requirement. And this example is this example, scalability case. And you have a single instance database, and you convert it to RAC database. Do I need additional memory space? Yes. If you expect more transactions, and you add the instances to support more transactions, then add additional 15% more shared pool and 10% more buffer cache. And shared pool, this is to maintain internal RAC-related metadata, and buffer cache, internally we will have duplicated copies spread across multiple instances. And also, during the instance recovery time, we need additional memory space because the instance recovery in RAC, instance recovery in single instance database is different. So in RAC environment, we will have to expect a little more buffer cache space. And also, we need a smaller buffer cache. If you simply convert single instance to RAC with the same pattern of workload and same amount of workload, but only when you actually add additional instance for scalability, then you add a little more information. And we have VDALA view that give you resource limit information and also SGA utilization information. Okay, parallel execution with a RAC environment. In RAC environment, you can run parallel execution servers in different way. For example, let me actually add additional note here. Suppose that you have a 3-node cluster, instance 1, instance 2, and instance 3. So 3-node cluster. And user connected to instance 1. And then initiated parallel execution. One possible option, the parallel execution is, and we start query coordinator in one of the instances, actually connected instance, and then we start parallel execution server here, possibly here, and possibly here. So we can leverage resources available across instances. That's a possible option. But you may not want to start these parallel execution servers in the remote instances. Instead, you may want to stick with only connected instance. Why? Because you don't want to make some unnecessary traffics. So if you want to stick with only connected instance to run parallel queries, then you can set this parameter. Parallel force local equals to true. By doing so, we start parallel execution servers only in the connected instance. That's what it is. But when you set equals to false, that means when needed, I want to start parallel execution servers across instances to leverage multi-instance resources. Which one is better? I don't know. That's what you have to test. If you have a small number of instances in your RAC configuration, maybe spreading parallel execution servers across instances may be a good idea. But if you expect long waiting when you run parallel query or so many block transfers across instances, then you may want to set parallel force local equals to true to localize your parallel execution only to the connected instance. So that's your choice. And later on, we will get into one more area. You can also isolate parallel executions only based on service location as well. And that's what we can discuss. And there is no practice activities in this lesson. So in this lesson, I gave you an overview of a RAC database and RAC one-node database, and also network requirement and storage requirement. And I also gave you a brief description of architecture and deployment options of a RAC database, and also I/O subsystem example as a part of this lesson. And that's for lesson 2.